All right, guys. So notes 8.1, differentiability, non-formal. You guys ready? So, yeah, point 8.5, yeah. So I wasn't going to do this. I was going to go right into notes 9, but one, we don't have enough experience, and two, activity 4 that you guys turned in, some of you drew so bad, like your tangents were so bad. Like that's not a tangent line. No, I'm letting you know. Like, look, some of you did this. You drew a, I'm just pretending. You drew a graph, and then I wanted a tangent line at this point, and then you were like, that's my tangent. And I'm like, what the heck is that? The tangent's supposed to go like that. So, no, I haven't. So thank you for letting me know. All right, here we go.
Remember, you have to press OK.
Yeah, I just did. All right, so here we go, guys. Question number 1. It says determine all values of x where the function f has a horizontal tangent line on the interval -9 to 9. Now remember, if you have a horizontal tangent, that means your slope is 0. The slope is 0. If the slope is 0, that means you have a horizontal line. Yes or no? So you read a graph left to right, and I look, okay, I guess you can make a point for a horizontal tangent right at that endpoint. But I think, look, notice I didn't put an equal sign, so we don't have to worry about it. So let's see, where do I have a horizontal tangent? It looks like I have one right there. And then it looks like I have a corner. So remember, at corners, you're not differentiable, because how's the tangent line going to look? And then I keep going, and it looks like I have another one at 1. And then it looks like I have one more at 6. So I have I have technically 3 tangent lines. I know that you can say you have a tangent line at -9, but notice I didn't put an equal sign. So you have a tangent line at -5, you have a tangent line at 1, and you have a tangent line at 6. So I'm putting the x values there. Does that make sense? Well, I have tangent, okay, sorry, I'm not being specific. I have horizontal tangents at -5, 1, and 6. Does that make sense to you guys? Okay, let's go to question number 2. It says determine all values of x where the function f has a vertical tangent line. So I have a vertical tangent line at x equals -6. And then let's see, where else do I have another one? At 4. And do I have any more? Nope. By the way, put this for good notes. You are not differentiable at -6. I'll tell you why in a little bit. Not differentiable at -6 and not differentiable at 4. Job, why are you not differentiable? You can draw tangent lines. Because vertical slopes start with the letter U, undefined. So when you write f prime of -6, you would write f prime of -6 is undefined because derivative means tangent slope. Does that make sense, guys? Okay, where else are you undefined? Where else is the derivative non-existent or not differentiable? At corners and cusp. So like at x equals 0, not differentiable. I'll put that here for good notes. Not, and I'll just put not DIFF. That stands for differentiable. At x equals 0, because that's like a corner, or that's like a cusp. It's an abrupt rate of, like an abrupt change. That's going to create a jerk. Cool or not cool? Okay, question number 3. So go to the upper right-hand corner. And it says, what did it say? Determine all values of x where the function f has a vertical tangent line on the interval -9 to 9. Now again, vertical tangents. I have one at -7. And I have another one, let's see, we're at x equals 3. Good job at -2. That's not a vertical tangent. And anywhere else? Nope, that's it. All right, let's go to number 4. Let's see what number 4 says. Use the graph of the function f of x shown below in order to determine all values of x in the interval where the function is not differentiable. Okay, for you to be differentiable, it must be a nice smooth curve, no corners, no cuts, no abrupt changes, and you have to be continuous. Again, as well as you're not differentiable wherever you have a vertical tangent. Cool or not cool? All right, let's read it left to right. Where's my first point where I'm not differentiable? Perfect. At x equals -7 because you have a vertical tangent there. And then I got, where else the next one? X equals -2 because you're not continuous there. And then there's another one, pretty close to x equals -2 because you have a what? A hole. So you're not differentiable at -1 as well. And let's see, where else? At x equals 5 because that's, yeah, vertical. You can say vertical tangent. vertical tangent, and that looks to be it. Does that make sense, guys? Okay, hey, no yawning. That's a demerit. That's a demerit. Oh, sorry, miss. Okay. Okay, yes. The word differentiable means, for the exception of vertical tangent, do you have a tangent? That's all it means. If you are discontinuous, there's no way you can have a tangent. If you have a corner, so check out this corner right here again. You see this corner at 0, -7? If I'm approaching from the left, that tangent would look like this. If I'm approaching from the right of 0, that tangent would look like this. Well, how's the tangent going to look right at 0? You can't. So that's why if you have a corner or a cusp, you don't have a tangent. So you're not differentiable. So you're not differentiable in corners and cusps. You're not differentiable if you're not continuous, like a hole or a jump, a vertical asymptote. And you're not differentiable if you have vertical tangents, because the vertical tangent is undefined slope. The slope of a vertical line is undefined. There we go. Cool or not cool? Rodriguez, you okay? Okay, sorry, miss. All right, here we go. Question 5. Use the graph of the function f shown below to determine all values of x on the interval where the function is continuous but not differentiable. Where are you continuous but not differentiable? Yeah, vertical tangent. So that's one of them. Let's see, do I have any others? I don't have any corners or cusps. At 3, that is an infinite discontinuity. That's a vertical asymptote. So you're not continuous at x equals 3. And it looks like that is it. Does that make sense? I hope that question comes out again with corners and cusps. Yeah, it does. Look at this one. Use the graph of the function shown below in order to determine all values of x on the interval where the function is not differentiable. So we read a graph left to right. We don't care about the endpoints because they're not emphasizing it. Where's the first point left to right where you're not differentiable? Perfect, because that technically is a cusp, but it's like a corner as well. X equals -7, and then well, at -4, it kind of looks like it's flat to me. Does it look like an abrupt change, like a corner or a cusp? Yeah, so I would say that is you're differentiable. I would say you're differentiable. We'll log in right now and we'll check. We'll do some problems together. Where are you not differentiable? X equals 0 because of a hole. And then where else? X equals 3, and then another one. X equals 4 because of a jump, and then I need one more. X equals 6 because of a vertical tangent. Man, that one had a lot. But not the -4. The -4 looks like it's legit. Cool or not cool? All right, where's the next question? Number 7. All right, the graph of the function f, don't worry guys, don't worry, we'll set you guys loose. F is shown below. If m is the slope of the line tangent to the graph of f at x equals -8, which statement best describes the value of m? Okay, go to -8. Draw a tangent line, just a small tangent line. Is that tangent line, does that look like it has a slope that is positive or negative? This is how you say positive slope. M greater than 0 means value is positive. Does that make sense, guys? Or does that not make sense? Okay. Let's go to the next one. Question number 8. The graph of the function f is shown below. Which statement best describes the value of f prime of 6? Go to 6 and then draw a tangent line. What does that look like to you? The slope is 0 and f, so what do you think the answer is? A, f prime of 6 is 0. Remember the derivative is your slope, your tangent slope at that x value. Are we cool right now? All right, turn the page, go to number 9. It says the graph of the function f is shown below. If m is the slope of the line tangent to the graph of f at x equals 0, which statement best describes the value of m? So at 0, I go, and it looks like I have a horizontal tangent. And if it looks like I have a horizontal tangent, that means my slope is 0. Gian, you okay, Gian? For sure. All right. Question 10. The graph of the function f shown below, if m is the slope of that, okay, so it's the same thing again, but they wanted it at 8, so I go to 8, and I draw my tangent line at 8. What type of slope does that look like? So, okay, now they want me to answer specific. Okay, does it look like my slope is, so here are my two positive ones. It's either letter B or letter C. So let's see, does that slope, okay, does this slope look like it's bigger than 1, or does it look like it's between 0 and 1? It looks like it's between 0 and 1. Because look, this would have been, Chav, how do you know by looking at it? Well, if I look at 8, and then I try to draw the tangent line as best as I can, and I know, so here's a different color, that point here and that point there, if I had this line, you see that line there? That line in sky blue has a slope of 1. Because I'm looking at the scales. See, up 1, right 1. You okay, Delgado? Okay, no, you're good, you're good. Does that make sense, Flores? So, does that sky blue line look like a tangent line? No, that's a secant. So I know for a fact that it's less than 1. It's between 0 and 1. Does that make sense, guys? Delgado, if you need to take a break, take a break. Okay, so look at activity 5 real quick.
But there's 2 more on the back.
Oh, there's 2 more on the back? My bad. All right. F prime of negative 2. So I go to negative 2, and to me that looks like a horizontal tangent. So F prime of negative 2 is just 0. All right, let's see what number 12 says. Again, but a negative 7, bam. Vertical tangent. If you have a vertical tangent, that means your slope is? What happened? Ask. Yeah, because this is... Okay. All right, no, you're good. Is that the last one?
Yes.
Okay, look at activity 5, guys. Go to... Let's do the rabbit question first. We'll do this one together. Bam. I know. It's doing calculus at the end of the day. I wish it would have been like last year. We had a pretty good deal last year. We had it in the mornings, but having it in the end of the day is definitely different because you're tired from all the other stuff. All right. The graphs in figure A show the number of rabbits and foxes in a small Arctic population. They are plotted as function of time for 200 days. The number of rabbits increases at first as the rabbits reproduce, but the foxes prey on the rabbits, and as the number of foxes increases, the rabbit populations level off and then drops. Figure B shows the graphs of the derivatives of the rabbit population. It was made by plotting slopes. Okay, thank you for letting me know. Yeah, this is what you would do if you were like a forest ranger, and that's your job to keep track of populations and stuff. All right, letter A. What is the value of the derivative of the rabbit population in the figure A when the number of rabbits is largest? Okay, so when the number of rabbits is largest, so this is rabbits way up here, what do you think that derivative is? Yeah, what is it, guys? Yeah. All right, guys, it's 0.
Yay.
Yes. Look, don't worry. I'll go over there right now. What is the value of the derivative of the rabbit population in figure A when the number of rabbits is the largest, smallest? So I guess let's do the largest first. All right, guys. Look, So look, when is it largest? At this peak. And at that peak, doesn't it look like I have a horizontal tangent?
Yeah.
I do. You could also have looked, if you wanted to, you could have counted and been like, oh, okay, that's that number, that's that right there. So this is my derivative graph right here. So it's 0. You guys see that? What is it when it's smallest? I'm looking at the blue line. Well, doesn't it look like it flattens out right here? So what is it when it's smallest as well? 0. So the derivative for letter A, when it's largest, it's 0, and when it's smallest, it flattens out, it's also 0. So 0 when it's largest. That's the Baron. You and Wilson are in the same team now. And when it's smallest, it's 0 as well. No more yawning, guys, because yawning's contagious, and you're gonna get me, and I can already feel it kind of coming, and I don't want it. If it comes out, man, everyone's getting a demerit. Okay, say it again. Of course, miss. All right. Oh man, guys, I can tell. I'm trying to fight it. I'm fighting it as hard as I can because I can tell that it wants to come out. All right, letter B. No more yawning. What is the size of the rabbit population when the derivative is largest? Okay, so when the derivative is largest, I'm looking at the derivative graph. This is my derivative graph, guys. When the derivative is largest, I'm at 20, and that just means that the population is growing the fastest. So look how steep this slope is right here. At that moment, at 20, 1700, this is my rabbit population. Put that right here. At 1700, the rabbit population is growing the fastest. See? What is that slope? In case you wanted to know what that slope is, I'm going to write, what do I write? R for rabbit. R prime of 20 equals 40. That means it's growing at 40 rabbits per day at that moment. No, not per second, per day, because this isn't time in units. Yeah, no, right? Yeah, no, this is, I think, scientifically accurate. This is coming from real data.
Yeah, no, that's actually real. Rabbits have a lot of babies. They have a lot. No,
Yeah.
you know what? That's
All right, don't worry, guys. Let's continue. All right, guys. Don't worry. Let's continue. Okay. This question 6, is similar. It's in your notes. It's on notes 8 specifically. So see if you guys can do that one. Look at number 7. Yes. Yes, we did. Yeah, we did. We answered everything. Oh, when it's smallest, what is the size of the rabbit population when the derivative is smallest? Well, when it's smallest, what is the size of the rabbit population? Yeah, almost 0, just barely above, what is this, 100? Whatever that is. Almost like 100 rabbits. Oh, okay. So, on letter A?
Yes, letter A.
On letter A,
We're just looking at the highest slope.
The derivative.
What?
The derivative is
What do you mean by that?
the rate of change.
Rate of change.
Yes.
Rate of change
Of rabbits at that time is 0. Notice that the number, okay, here's how you should think about it. I'm trying not to throw you guys too much immediately. You see how that's a maximum? So my tangent slope just went from positive to negative. It's changing right at that moment. It was positive and now boom, maximum, and now my population is decreasing. Well, think about it. That makes sense. I must have a maximum population there because my slope, my instantaneous rate of change, just changed from positive to negative. If your rate of change changes from positive to negative, that means I have a maximum because I was going up.
So this is the same thing as when you were saying, like, when you drive and you go from 60 to 65 miles.
Oh, that's intermediate value theorem. That was different. Don't get the theorems together.
The slope of the tangent.
Slope of tangent. That's it. Slope of tangent.
Slope of tangent.
Yes. All right. Yeah. No, they're not. Well, when we. All right, guys. Don't worry, because I want to make sure that we have enough time for you guys, because you guys have your ring ceremony, and I want to make sure that we tackle what we can during this class. At question number 7, yeah, but you guys need to get ready and all that good stuff. All right, question 7. Determine continuity and differentiability of the given function at x equals 0. All right, this is not the right way to do it. All right, Ian, focus. All right, hey, don't worry, no more TikTok, guys. Come on, focus. Determine the continuity and differentiability of the given function at x equals 0. So for this, guys, this is not the right way to do it. This is just showing you with a grid. Do I know how this function looks like for x greater than 0? Yes, it looks like this. Dot, parabola going up. Yes or no? Do I know how this graph looks like negative x squared for x less than 0? Yes, it goes like this. Yes or no? And I didn't draw it perfect. I wish I would have drawn it a little better. Okay, on this graph, right at 0, what does my tangent line look like? Yeah, is it a flat line? Is it going up? Is it going down? Right at 0. Tangent line. It's flat, right? So when this says determine the continuous differentiability of the given function x equals 0, you're continuous. It's nice and smooth curve, and you are differentiable at x equals 0, and the derivative at 0, f prime of 0 is 0. F prime means the F prime means derivative. F prime means slope of tangent. F prime means instantaneous rate of change. It means a lot of things, right? So, okay, let me graph this function without a grid. Still not perfect. Still not perfect. Well, I still not. I wanted to miss. Okay, there it is. That's about as perfect as it's going to get. Look at that red dot right there. So pretend this is this graph right here, not perfect. At that red dot, doesn't it look like I have a horizontal tangent? Yeah, it looks like it takes a little dip, but it looks horizontal tangent, guys. So that means my slope is 0 there. Cool? Okay. Yay or nay? Okay. So this one, question number 8, is an easier version of question 10. So go to question 10. I just added this today after, this is actually your question, but I put it in here. I just added this today. It's from UH, certified fresh. I literally just typed it out. UH question 9, definition of derivatives from the certified fresh. I typed it out. Okay. Determine the values of the constants b and c so that the function given below is differentiable. Okay, so by now, we're not perfect yet, but you should have, we haven't done a formal definition of this yet, just yet. It's coming, don't worry. But by now, we should have something in our heads that's saying, well, to be differentiable, you got to be continuous, and the left side derivative must equal the right side derivative. So let's do the continuous part first. At x equals 1, this function in the top better equal the function in the bottom. So at x equals 1, 11 times 1 cubed better equal b times 1 squared plus c times 1. So 11 equals b plus c. That looks like a 13. Let me write it. B plus c. Yeah, c times 1. Equation 1. I tried to fix my writing. Does everything look okay now? Does letters look like letters? Numbers look like numbers? Okay. All right, here we go. Now I need my left side derivative to equal my right side derivative. So at the moment, we don't know how to take a shortcut. Don't take shortcuts. At the moment, we know, okay, so let's find the derivative of the top at x equals 1. So how do we do that? We're like this. F prime of 1, and I'm going to put it here from the left because we don't know proper notation yet. From left. I should be putting a little minus sign, but no big deal. From left, f prime of 1 equals limit, as h approaches 0, of f of 1 plus h minus f of 1 all over h. Now, if I'm approaching from the left, I'm using the function 11x cubed. Man, I can't talk. Are we okay with that? Okay, so here we go. F of 1, I'm just doing this on the side. F of 1 is 11 times 1 cubed, which is just 11. F of 1 plus h is 11 times 1 plus h closed to the third power. If you know Pascal's triangle, the 1, 3, 3, 1. Okay, if you know it, you know it. If you don't know it, don't worry. You can just expand it to what you do know. 1 plus h squared times 1 plus h. That's the same thing as 1 plus h cubed, right? Okay. And I can do the 1 plus h squared pretty fast. So can you? 11 parentheses 1 times 1 is 1. 1 times h is 1h, but you can have 2 of those, so 2h. H times h is, and I still have that 1 plus h. I'm going to distribute. Don't worry, in a little bit, we'll go ahead and distribute the 11. I'm going to distribute the 1 to both of those. So here's what I have. 11 bracket, let's see. 1 times 1 is 1 plus 1 times h is 1h. I wrote HH. 1h. And I'm done with the 1s. I go to the 2h. 2h times 1 is 2 plus 2h, man. Plus 2h times h is 2h squared. So I'm done with the 2h. Now I'm going to jump to the h squared. H squared times 1 is h squared. H squared times h is h cubed. Combine like terms, so let's see what I got. 1 plus 3h plus 3h squared plus h cubed, and distribute the 11 to every term. So 11 plus 33h plus 33h squared plus 11h cubed. It doesn't matter. Brackets, parentheses. It's because I already have parentheses, and I didn't want to put a large parentheses because some people might not. You know what I mean? All right. And man, I should have put more room in here. I'm sorry, guys. All right, here we go. From the left, I'll just change the color and write over here because you don't need this space for number 9. F prime of 1 is equal to limit as h approaches 0 of 11 plus 33h plus 33h squared plus 11h cubed minus 11, that's the f of 1, all over h. Are we okay? Okay. Let's see what zeros out. 11s. Yeah, if you weren't here, because we did this a whole bunch yesterday, so you might be a little lost. But don't worry, we'll fix it. What can I cancel out now? No, you can cancel. Because I can factor out an h. I can cancel an h, right? Because when you factor it out. No. Oh, yeah, you can. But it's going to, yeah. Yeah. You're going to get the same thing again, 11 times 3. So you're going to get the same answer anyways. You know what I mean? All right, here we go. What's going to cancel? Or what's going to zero out now when I plug in a 0? Perfect. That will zero out, and this will zero out. So the only thing you're left with is 33. So that's my derivative from the left-hand side. I know, that was a lot of work just for that. We're not even done yet. All right, here we go. So I know that my left side derivative better equal the right side derivative. So I'm gonna come up here, guys. I'm gonna use this space because I don't need it. I'm gonna find my from right. I'm going to do it in this color. So from right of x equals 1. So here we go. I need to do, what do I need to do? I need to find f of 1. F of 1 is b times 1 squared plus c times 1, which is b plus c. Yeah, I'm doing my derivative. So I need f of 1 and f of 1 plus h. And I need f of 1 plus h. Close it. B parenthesis 1 plus h, close it, squared, plus c parenthesis 1 plus h, close it. I'm doing my derivative at 1. Ask me, Flores. Oh, you see how I'm going from the right? So I'm finding my derivative for this right here at 1. And they just have letters like B and C, so are we caught up? Okay. Here we go. I'm just expanding it, guys. I'm not doing any calculus. I'm just expanding it. B, parenthesis, 1 times 1. 1 plus 1 times h is 1h. I'm going to have how many of those? So 2h plus h times h. H squared. Plus, and then distribute this c. C plus ch. Are we okay? All right. Distribute the b. B plus 2bh. Sorry. Plus bh squared plus c plus ch. It just sounds funny, that's all, but I don't mean anything by it, so hopefully no one got mad there. Are we okay so far? Okay, here we go. F prime of 1 from the right, equals limit as h approaches 0 of all this, b plus 2bh plus bh squared plus c, I know, plus ch minus f of 1, which is just b plus c, but a lot of you are making the mistake of not distributing. So distribute your negative, minus b minus c. And all this is over h. We're almost done, guys. We're almost done. So catch up. I hope you have your fries for the ketchup. I hope you brought your eyeliner for the makeup. Makeup. Never mind. It's not. Yeah, I messed it up. If it was makeup day, like like you make up stuff, makeup work, I could say, did you bring your eyeliner? Because it's makeup day. Makeup. I'll stop. I'll stick to math. All right, here we go. The B's cancel out or zero out, and the C's zero out. Are we okay? Now I can factor every single term has an H. I can factor out an H. Bam, that one's out. Bam, I have one left. Bam, that one's out. And then what is H approaching? Okay, you want me to rewrite it? Okay. And then what is H approaching? So I'm left with 2B plus C. This is my derivative from the right-hand side where B and C is a constant. All I got to do is equal this to, this is my equation number 2. What was the left-hand side? So I'm going to equal that to 33. So I'm going to write equation 2, and I'll put it in black here. Equation 2. So 33 equals 2B plus C. And there it is, guys. I have everything I need to get B and C. Chav, what are you talking about? Here's equation 1. See how equation 1 is B plus C? It doesn't matter which one you do. So I think earlier we solved for C and we plugged in B, but it doesn't matter. It doesn't matter which one. I'm going to move the B to the left. So look, C equals 11 minus B. Do you guys see that? I wanted to do something different than last time. So now this is what I'm going to plug in right here. So look, 33 equals 2B plus 11 minus B. Do you guys see that? Combine like terms. What is 2B minus B? 1B, and then move the 11 to the other side. What's 33 minus 11? So B equals 22. Now that I know that B is 22, can I solve for C? Yes, plug it into the original. The C equals 11 minus B. What's 11 minus 22? So C is negative, what is that? Negative 11? And there it is. Is that what we got last time? Okay. How do we feel? I know, this was tough. Later on, probably tomorrow, I'm going to show you something called the power rule. You probably already know it. And you're going to be saying, man, Chav, you made my life hell the last few days. I could have just used power rule to do all of these. Yes, but right now we need you to suffer. Did I say something bad? I didn't say anything bad, right? Tomorrow, yeah. Well, maybe. It depends if they do all their stuff. Because if they don't have enough experience, then I got to keep pushing it. You know what I mean? All right, guys. There is one delta, and the delta looks exactly like the notes. Because I don't know if you saw, but look, I took it from delta. Yeah, so we're giving credit to delta. So don't worry, YouTube, I'm giving credit. So there is one delta. It looks exactly like the notes. And then make sure to finish activity 5. I would like it today, but I understand there's a lot going on today. So you can turn it in tomorrow. So, but make sure that we take advantage of right now, guys, and, do as much as we can right now. All right, guys, that's it. Thank you guys for flying room 206. We know you have a lot of options.